My name is Tim Smith, and I have to say I've had the great honor of being the chairman of the American Society of Landscape Architects Stewardship Committee. And on behalf of this committee, I'd like to give a big thank you to Belgard Hardscape, who has made this opportunity possible, working with our committee. Without them, we wouldn't have had this great space. And of course, without them, we wouldn't have the great social event that's going to occur on the rooftop of this beautiful hotel. I have been up there, and it's really pretty cool. I also want to give a big thank you to the Stewardship Committee. Many of those members are sitting right in this front table. So thank you all very much with all the effort. I just happened to be the one up here speaking, but I didn't do it all by myself. Thanks again. I'd like to give you a brief description of why we're here today. I know most of you have an agenda in front of you, but the reason we're doing this is several reasons. One, our Stewardship Committee has several goals, one of them being how can we continue to educate landscape architects, our fellow members, as well as civil engineers, architects, people that are on our design teams. How can we educate them to do more sustainable design practices? How can we help them be better stewards of the land? We're not claiming to always be the experts on it, but we want to provide opportunities for learning. And like today, an opportunity to share. Today's event is not just about you listening to the speakers lecturing to you, although there's going to be quite a bit of that. The success of today's event is dependent on you, and I really mean that. What's unique about today is that we have landscape architects, civil engineers, landscape contractors, and interestingly enough, not that it's that big of a surprise, but we have city agencies and county agencies here. The idea is that we can all talk together. Too often, we are all in our own offices dealing with what's given to us, whether it comes from the requirements by the state. The landscape architect is dealing with what they've been given by the civil engineer. The civil engineer is dealing with what the landscape architect wants. And sometimes there's some bitching back and forth about what is put on our plate. And the geotechs will require certain things that might make it difficult for us. And so instead of just bitching about it, let's talk about it. And that's where you come in. There's going to be some ideas presented today. Some of them you will have already known about. Some of them may be new. But please don't be afraid during the question and answer periods, and there are 3 of those, to not only ask questions, but to raise issues. You can give advice. We have a room full of experts. So critique the presentations. Except for mine, of course. I've already told our committee that mine, you cannot, because I cry, and it's a mess. Josh has got some Kleenexes already for me if anybody tries to critique my presentation, which will come later, purposely later on, so I can get psyched up for it. Anyway, so let's get on with this event. But I already skipped over something. Just so you know, the 3 question and comment periods are one after Stephanie Gaines, who's going to speak next, and then during the second half of the event, which has a 15-minute break, somewhere around 3:30. Since we got started late, it'll be a little bit later than that. Then I will give a presentation. There's some time to ask questions or make comments. No critique. And then at the very end, whatever time is left, there'll be more time after you've heard some or seen some interesting presentations. So with that, I'd like to introduce Stephanie Gaines. She's with the County of San Diego, and she's going to talk to you about the current MS4 requirements and the new MS4 requirements. So let's give a nice welcome to Stephanie Gaines, please. And I'm going to try to figure out how to do this.
Yes, I was taught well.
Yes, you are. There.
Here we go.
Great.
Great.
Thank you, everybody. Good afternoon. Can you hear me well enough? I can hear myself quite well. As Tim said, I'm working with the County of San Diego Watershed Protection Program, and many of you may, or some of you may not know, that we've recently had our new MS4 permit adopted on May 8th of this year. The Regional Water Quality Control Board for San Diego adopted R9 2013-0001. And that's going to take us into the next 5 years of stormwater regulations. So as we go through this, I don't mind if you have questions during the presentation, but most likely if you wait a few slides, I'll probably answer those questions for you, or we can hold them till the end. Either way works for me. Also, I just wanted to, well, let's get into the agenda and we'll go ahead and get started. What we're going to talk about today is a little bit about some background and regulatory framework for the permit. And as Tim alluded to, I'm going to do a little bit of comparing and contrasting as it relates to your industry about what the current regulations are and what, where the new regulations are going. We'll talk a little bit about the new permit structure, our water quality improvement plans, that we're going to have to develop over the next couple years, new development requirements, which is really going to be the area of focus that you'll probably be interested in or most interested in, a little bit about stakeholder process and timeline, and since today's about some creative solutions, I thought we'd talk about one of the projects that I'm working on, which is a Proposition 84 grant through IRWM, or Integrated Regional Water Management Planning Process, that I'm partners with the County Water Authority, the City of San Diego, Association of Compost Producers, and some others, and Surfrider Foundation as well. So as we talk about the regulatory framework, I always find that it's beneficial to have people understand where these regulations come from, so you don't think that the county's just on you and trying to get you to do things for no reason whatsoever. We actually have, there's an impetus for all this. But before I get started, I just wanted to go through some terms. You may hear me use the term co-permittee. A co-permittee is one of the municipalities who is an owner or operator of the storm drain system, and we're the named people in the MS4 permit that have responsibility for making sure the permit is implemented. You may also hear me say terms like TMDL, Total Maximum Daily Load. That was a recent regulatory action that was adopted by our regional board and implemented to mitigate certain pollutants of concern in local waterways. And as we go through some of these technical discussions, you might hear me say, throw those terms out, and I just wanted you to be aware of them. So from the regulatory side, it all starts at the federal level with the US EPA and the Clean Water Act. Section 402 of the Clean Water Act requires that permittees or co-permittees have a municipal NPDES permit, that's National Pollutant Discharge Elimination System permit. Now, the Clean Water Act has been in force and effect since the early 70s, but the NPDES section has been in effect since 1987. That was a relatively new addition to control pollutants through stormwater and urban runoff. We also have to have a new permit every 5 years, and that's why they're adopted on an iterative approach. And one more interesting fact about Section 402 of the Clean Water Act, it does not allow for what we call backsliding. In fact, there's an anti-backsliding rule. And so what that means is each iteration of the permit has to be at least as stringent as its predecessor. In fact, more often they become more and more stringent, as you will see with this new permit that we're going to talk about today. Now, most states some states can implement the permit, their MS4 permit, directly by implementation of the Clean Water Act and through the Clean Water Act. Other states like California have also promulgated their own act, the Porter-Cologne Water Quality Control Act here in California, that the State Water Resources Control Board implements at a state level, actually has our basin plan in it, our ocean plan, our thermal plan, and other plans. So it's basically the Clean Water Act with a lot of additions specific to California. Now at the Regional Water Quality control board level or at the local level, you'll see from the map that's there in front of you, California is broken up into 9 regions. San Diego County is unique in that we're actually split between 2 regions, and it's kind of hard to see on this little map, but we're split between Region 9 and Region 7, and that dividing line is the Tecate Divide, where the mountain peaks are. So if you go east of the Tecate Divide, you're in Region 7. If you go west of the Tecate Divide, you're in Region 9. Region 9 also encompasses parts of Riverside County and Orange County, the south parts of them. They're co-permittees with us now in this new permit as part of Region 9 as well. And don't worry, there's not going to be on the test on this later. I just wanted to let you know that as you get down to the local level now, such as with the County of San Diego, we have to implement the permit through our local codes, our local ordinances, and through guidance manuals and technical manuals that you see up here. So fundamentally at the County of San Diego, and I'm sure the other municipalities have similar ordinances in place, we have the Watershed Protection Ordinance that is the first line of defense that helps us implement the permit and creates a lot of those controls that you'll see on development projects. We also have the landscape ordinance and the water efficient landscape design manual that was recently implemented to help us with irrigation issues, things of that nature. Our standard urban stormwater mitigation plan is the development Bible, if you will. It contains currently low impact development and hydromodification controls, and those development controls that are subject to stormwater management plans. Also our LID, or Low Impact Development Handbook and fact sheets. And on a peripheral sense, when you look at development projects that are subject to Resource Protection Ordinance and the Multiple Species Conservation Program and the Biological Mitigation Ordinance, to some extent water-related features can be peripherally addressed in those 2 ordinances as well. And again, it's not anything to understand except that we do have to implement these permits at a local level, and these are the mechanisms or the vehicles that we use to do that. And so when we're talking about what we're trying to control and what we're trying to enforce with this permit, we're talking about the municipal storm drain system. As owners and operators of municipal storm drain systems, we call it the MS4, the Municipal Separate Storm and Sewer System, we have to make sure that anything that goes through those systems, that's conveyed through those systems, doesn't cause a problem to receiving water. So in that effect, that's how municipalities are trying to protect surface water quality, by making sure that anything that goes into our storm drains goes in clean and comes out clean. And that can be quite a challenge, as you can imagine, because sometimes these systems are not closed systems. We're not just talking about a storm drain. Sometimes we're talking about culverts under roads. Sometimes we're talking about open channels, open systems, open flood control systems. So, aerial deposition could affect that. And somebody else had asked me a question earlier today about our storm drains being separate from our sewer system, and that is in fact true in San Diego County. Predominantly we have, and that's why it's called an MS4, a municipal separate storm and sewer system. Storm drains and sewer systems are not connected, so anything that conveys through there, of course, is going to end up in the receiving waters, and if it ends up there with pollutants in it, then it also impacts the receiving waters as well. Now there are some areas where we've implemented what's called low flow diversion. Those are primarily near the coast, and those are kind of like a last line of defense to take storm drain waters off into the sanitary sewer system to a certain capacity, and that's to mitigate flows into the ocean so that we don't have a pollution problem with the ocean. The new structure for our permit is really a complete departure from our existing permit, and this is where I'm going to talk about some of the compare and contrast for what we have in effect now and what's going to be in effect with this new permit. The map that you see in front of you is that map of Region 9, and that little squiggly line right up there on the right-hand side is the Tecate Divide. So that's the division line that as you flow westward would be keep us into Region 9. And as you can see, there are 3 distinct segments under the 2007 MS4, what we're calling the current permit. There's the South Orange County, the South Riverside County, and the San Diego County sections, all have their own unique permit, and all on different cycles as well. So for example, the 2007 permit is actually the 2007 permit for San Diego County, and for that section that you see that is San Diego County there. Orange County is, I believe, up for renewal in 2014, and Riverside County in 2015. So we're all on a little bit different cycles as we go through the permitting process. That kind of does create a problem for our regional board, because at any given time they've got a permit in the cycle in a varying different degree in that cycle and different process. This is our new MS4 permit structure. We're all going to be under one MS4 permit, so one regional permit throughout the entire MS4 drainage system region. And what that means too is that since we have 10 watershed management areas, we're now going to have 10 unique leads instead of 3 different leads for each permit, for the entire permit. Now, as you can imagine, each of these different colored areas represents a different drainage basin. The aqua up there starts with San Juan. The next one over with the number 6 in it represents the Santa Margarita. As you travel southward, you're into San Luis Rey, Carlsbad Watershed, San Dieguito, Los Penasquitos, San Diego River, the best watershed in the county. That's my watershed. The San Diego Bay watershed is actually made up of 3 distinct drainages. There's the Pueblo watershed, which is, I think, what we're standing in right now, the Sweetwater River watershed, and the Otay watershed. Since they all drain to the bay, those were lumped together by the regional board to make it easier to manage those watersheds, because they're all draining to the same area. And finally, the Tijuana River watershed, which has its own unique challenges because there's a binational committee that has to work on some of the flows that come in from Tijuana. What you don't see on this map is how large the Tijuana River watershed really is. It really goes pretty far down into Mexico, and it drains out into Imperial Beach. And I think some of you have read in the newspaper some of the issues we have with raw sewage coming across, and that's a big problem that we're trying to work with too. So as far as leads, as I was saying before, each of these will have a distinct lead, and each of these will have a plan developed for them, and we're going to go into that in more detail next. The little number in each of the watersheds represents the number of co-permittees that will be a party to water quality improvement plan development and a party to participating in those watershed management areas. So currently, in our current structure, what we have is what's called a Watershed Urban Runoff Management Program. That's in our 2007 permit. The Watershed Urban Runoff Management Program is kind of, I guess you could call it prescriptive. It's very activity-based. Now, we know that we have issues in our watersheds, and we know pretty much from years of monitoring and TMDLs and everything that we've had adopted recently, what type of issues that we have in each watershed. And because our WURMPs, or our Watershed Urban Runoff Management Plans, had to be activity-based, basically what we did is put into effect activities to mitigate those problems. And I'll give you an example. In San Diego River, we know that bacteria is a huge issue. And the markers that we test for our fecal indicator bacteria, Enterococci, things like that. So knowing that pet waste was one of the problems that we were having, we put together pet waste management programs, and that consisted of a series of different surveys. I know that the city conducted surveys, the county conducted surveys, and then handing out pet waste dispensers and pet waste bags to pet owners at different events so that we could encourage them to pick up after their pet each and every time. We also learned through community-based social marketing that if we get people to sign their survey that says, I commit to pick up after my pet each and every time, they were more likely to actually implement that behavior. So we implemented that in all of our surveys. We asked for a signature from people. What we were able to do was to count the number of surveys and to count the number of dispensers and bags we handed out, but not necessarily see a huge change in the bacteria load in the watershed. So we weren't able to see that activity directly benefited. Not to say that picking up after your pets isn't a good thing. You all had better do it. But what we had then under that program was a very activity-based and very prescriptive type program. Some of the other things we have to do under this program is we have to street sweep at a certain frequency. We have to inspect certain types of businesses that are considered high priority businesses a certain amount of times. So it was a very prescriptive type program. The new shift that we're going to is what's called a water quality improving planning process. And as I mentioned before, and I'm going to go through this quickly and get to the next slide, because there's 10 watershed management areas in the region, in Region 9, including South Orange and South Riverside County, and you can see the drainage is a little better here. Each of these is going to have built for it a water quality improvement plan that identifies its priorities. It is going to shift us to a watershed focus instead of an activity-based focus. So we're going to truly have the opportunity to look at some of the priorities and to implement controls and programs and projects specific to those priorities. And just kind of an interesting side note, this permit cycle requires us to have a very heavy public participation and outreach process required. So while you may see notifications coming soon for large-scale public processes or public meetings to kind of describe the water quality improvement planning process, there'll also be consultation panels that will help us go through some of the information that we're receiving at public meetings and help us build these water quality improvement plans. So as I mentioned, the process is going to be a pretty lengthy process. We have 2 years to put our water quality improvement plans together in each of the 10 watershed management areas. And that's the next 2 years, not 2 years sequentially. So I don't have 20 years to put together plans. The first part of the planning process is to develop our priorities and to look at our water quality conditions. So we're going to be required to look at the receiving waters, to look at the water or the discharges coming out of our MS4s, to look at what we already know are issues. For example, I mentioned TMDL, the bacteria TMDL that is in 6 of the watersheds here in San Diego County that was already adopted by the regional board. We know that in those 6 watersheds, bacteria is probably going to be one of those priorities because we've already done a lot of analysis and modeling to that effect. The good thing about this is we have about 6 to 12 months to develop our priorities, some of which are like I said, through the bacteria TMDL process have already been established and identified. Once we're done identifying our priorities, we have to turn a product into the regional board that says, here's our priorities, and then go on to the next step, which is to identify our water quality improvement goals, our strategies, and our schedules for addressing those priority concerns in each of the watersheds. That means that we're going to be looking at some numeric goals, and that could be a parts per million numeric goal, or that could be a numeric goal that says something like, we'd like to address over-irrigation and reduce over-irrigation in this watershed by 10% in the next 3 years. That could also be the type of numeric goal that we may see in this next permit as we develop our water quality improvement plans. Finally, we have to be able to assess ourselves. We have to not only be able to assess the individual projects that we put together, but the program as a whole, to make sure that the program is coming together and is working properly, and make sure that that the programs we're putting into place are working and that we're getting results. And in order to do that, we're putting together a monitoring and assessment program to assess that. Finally, another big component of the permit is to implement what's called adaptive management, or we call it the iterative approach and adaptive management process. And what that means is we're not only through our monitoring and assessment program assessing our program, but we have a process put in place that will allow us to go back to the beginning if we reach some of these goals and reassess. Now that we've reached, let's say, the bacteria goal, because every pet owner in the watershed is picking up after their pet, and we've achieved that goal, what's next on the list and what can we do next that will be beneficial to this watershed so that we can reach ultimately those basin plan standards and objectives. One of the interesting things that's in this permit too is the alternative the watershed management area analysis, which is an optional process for water quality improvement planning. What this does, this is linked directly with the alternative compliance. In our permit, we are required to make sure that these BMPs and controls are done on site. But we realize that not every site is going to be able to take or withhold or withstand all of the best management practices on that site, and that there need to be some option for some off-site mitigation or for some other opportunities so that we can reach these water quality objectives and goals. And that's where the alternative compliance is really taking us. So the alternative, or the area analysis, will actually allow us to look at the watershed and to find some off-site sites and solutions for implementing controls for water quality, and will also allow us to bring back in some of the hydromodification exemptions that were taken out of the new permit that are in our existing permit today. And we'll get to hydromodification at a later slide, so we'll go into that in more detail in a minute. So the benefit of doing this alternative analysis or this area analysis is that you can come up with candidate project for the off-site mitigation or for the alternative compliance process. And some of the off-site projects that we're looking at are the ones that you see here on the list. The restoration and rehabilitation of streams, being able to retrofit infrastructure to allow it to retain or infiltrate, groundwater recharge and augment water supply, and also to help preserve floodplains. Now, the new development regulations are actually changed quite a bit, and they're quite a bit more stringent. So I'll just go right into these quickly. This is basically what is in what has changed from our current permit to our new permit. In Development Planning Section 3 of the new permit, what you're going to see is a change to the priority development project categories. Is everybody here familiar with a priority development project and what that means? I see no hands raised. I see a lot of heads shaking. Priority development project is a concept that's in our current permit. Basically, if you meet certain criteria, if you're a certain size project, if you're a developer and you're coming in and you're developing a commercial or industrial site and it's at least 1 acre in size, you're considered a priority development project and subject to the controls of the major stormwater management plans. And there's certain controls that you have to put in place. In our 2007 permit, you had to implement low impact development on site if you were a priority development project, and that was back in 2007 the new criteria that we had to develop. Now you're going to have to develop a whole host more criteria or projects when you become a priority development project, and we'll go into that in just a minute. You have to retain water on site. You have to retain flows on site. We're looking for a zero dry weather discharge in this new permit, and that's going to be really challenging to obtain, we realize, in some cases. Our hydromodification controls have changed. What they're looking for now is different calculations for development and redevelopment, and avoiding certain sediment yield areas. And again, we're going to go through this in more detail in a minute. And then, of course, we have the opportunity for alternative compliance, but only if during the water quality improvement planning process we do the area analysis, the additional analysis. Oh, and the anti-backsliding, that was very important. I mentioned Section 402 of the Clean Water Act early on in the presentation. The reason that a lot of this ended up so stringent in our current permit is because, as I mentioned before, South Orange County and South Riverside County are on different schedules. A lot of this language for priority development project, retention, and hydromodification is in the South Orange County and South Riverside County permits. And so because we have the anti-backsliding regulation from Section 402 of the Clean Water Act, we couldn't go back to something that was less stringent for them, as we're now all under one permit. And that's why that new structure is so critical to us. So we had to move forward with South Orange County and South Riverside County and implement all of this into San Diego County's new regional permit. So I mentioned the priority development projects. Like I said before, under the 2007 MS4 permit, if you were a residential development and you were developing 10 dwelling units or more, you were considered to be in a priority development project category, and you had to implement low impact development on site. If you were a commercial or an industrial site and you were developing a site that was 1 acre or greater in size, you had to implement low impact development on site. Now the rules have changed. If you're developing a commercial, residential, industrial site, now we're into 10,000 square feet of impervious surface, which, as you realize, can add up quite quickly. You could have 10,000 square foot homes, and now you're a priority development project. And most homes that are built today are not 1,000 square foot homes. I think we know that. Also, residential driveways, which were previously exempted in our 2007 permit, are now added in this permit. So, so if you add a driveway that adds up to 5,000 square feet or greater, that's going to kick you into the priority development project category, and you'll have to implement additional controls. Now, there is one caveat with this section, and the caveat is that if you use permeable pavement, where's the permeable pavement, guys? If you use permeable pavement, the permeable pavement that you use will not count towards your impervious calculation. So you get a little bit of a break there if you use permeable pavements to design driveways or some of the hardscape in the project. The reason why priority development projects in this permit are an issue, or going to be an issue to future developments, is because now we don't just implement low impact development. Now we have to actually implement 4 types of controls. We have to implement source control BMPs to mitigate at the source. And those can be as innocuous as something like storm drain stenciling, or if it's a commercial site, making sure they cover up the equipment so that materials don't leach out during a storm event. You have to implement treatment control best management practices. You have to implement low impact development to retain the 85th percent storm event in a 24-hour period. And you have to implement hydromodification controls all on site if you're a priority development project. So that's why priority development projects are so important to understand. Yes. The 4 types of controls. Yeah, there's source control BMPs and treatment control BMPs, low impact development, and hydromodification. There will be a test on that later. No. But wait, there's more good news. Yes.
What if it's like a single residential, but the driveway is more than 5,000 square feet?
Then you're going to be classified as a priority development project unless you use some sort of permeable pavers, and that permeable paver won't factor into your calculation. Yeah. There are some exemptions, though, and that's what I'm going to get to right here. If you're going to be developing projects such as sidewalks, bike lanes, trails, and you're going to use low-impact development with either biological filtration or permeable pavers in the hardscape areas, those would be exempted. Now, every project that comes into the municipality to ask for a permit to do something is going to have to implement, at the very minimum, source control and LID to their project. It's those projects that are a priority development project that have to implement all 4 controls unless they're using one of these exemptions. So if you're going to be developing sidewalks, bike lanes, and trails and use a permeable material, permeable concrete, permeable asphalt, permeable pavers, DG, that type of thing, those would offer you an exemption. And so you would only have to implement the 2 controls, not all 4 controls. The other thing is the permit is really, really pushing the US EPA Green Streets, which as a planner I tend to like. I like the US EPA Green Street option. And some of the pictures up here you'll see are, one of them, the one in the center there is actually from the US EPA Green Street site. Being able to use biofiltration, holding cells, swales, permeable pavements, planted areas, reduced lane widths, multimodal transportation, those types of things will actually also offer you that type of an exemption too. So I do know that we're going to be encouraging projects to implement US EPA Green Streets and encouraging them to use LID on their trail systems and bike lanes whenever feasible, so that they can be offered these exemptions in their projects. Now this is the new retention standard. And this is probably going to be the biggest thing for anybody in the landscape business to date, because fundamentally, if you're looking at a site as it comes into the as it comes into the municipality and they're looking at it, they're going to be asking you first and foremost to retain all storm events and to retain all runoff on site. So that's going to mean, you know, no over irrigation, no overspray. If there's a rain event, you have to be able to design your best management practices to contain the 85th percentile storm event in a 24-hour period. Generally speaking, in San Diego County, we have, 7 to 10 inches of rain annually. So you're talking about the first flush or about the first 1 inch. Depending upon the isopluvial map, it could be a little bit different in different parts of the county. But that's what you have to design your best management practices to. If you can't intercept it, store it, infiltrate it, or evapotranspirate it, there are options for biofiltration and for treatment and use if you use the alternative compliance. And one thing I just remembered, I don't think I told you, if you look on your handout, you'll see these different sections. Those are sections in the permit where this language can be found. And so, and as you go through the presentation and the handout that you had, if you look at the pages on there, there's different sections. Most of this is going to come from the development section in section E, past the jurisdictional section, but in the development section. So you can go back and see the actual language, which is, you know, very technical and very stringent to listen to. So the chart that I have here is really giving you a little more detail about the options that you have. First and foremost, the permit is going to require you to retain that 24-hour storm event on site, period. But if you can't retain, you can use the biofiltration option, BMPs, but they have to be sized appropriately. If you're using biofiltration, it has to be sized to treat 1.5 times the design capture volume not retained on site. And if you're using a flow-through device, it has to be sized at 3/4 or 0.75 times the portion of design capture not retained on site. Finally, if the municipality has done the off-site compliance or this alternative area analysis, you could use off-site flow-through treatment control BMPs. They have to be designed to remove pollutants to the maximum extent practicable, or the MEP, that's an MEP standard. And then, of course, these have to be sized to the criteria that you see here on the screen too. The H or M pollutant removal is high or medium pollutant removal efficiency. You have to also mitigate for the volume you did not retain on site at an off-site compliance site. I know it gets a little bit technical, and probably as the landscaping industry, you're probably not going to have to worry about off-site compliance as much, but there are 3 options to work with this new retention, with the new retention requirement. One thing that I wanted to bring up, though, and I think that a lot of people in this industry will do, is you're probably going to design ponds, right? I mean, how many people out there design ponds as part of a landscaping, or water features as part of landscaping? There's probably a number of you that will do that. And I understand that the new vogue in ponds is these saline or saltwater ponds. That's actually called out in our permit. It's problematic because you cannot discharge that when you're draining or maintaining these ponds to the storm drain. In fact, it falls under section E2C, where the chlorinated pools are called out. Just like with a chlorinated pool, you have to take all of the chlorine and all of the chemicals out before you can discharge that volume of water into the storm drain. These actually can't be conveyed to the storm drain. They have to be conveyed to a landscape area, which I don't know about you, but I happen to know that salinity is not necessarily good for soils or plants. The other option that's called out in the permit with ponds is being able to flow it directly to the ocean or to another saline site via a conveyance pipe or a concrete line channel. So there are options to do it, but if you're going to be designing ponds and with the new, I guess the new vogue in ponds is doing these saline ponds, make sure that maintenance is part of your design when you're thinking about these ponds, because there's going to be some criteria about where these ponds can be discharged in the future. So hydromodification is a unique feature. Probably a lot of you don't know what hydromodification is. It's basically downstream impacts to streams that erode them away at a much faster rate as a result of upstream development that did not place the proper controls in stormwater or urban runoff. And so you've got higher velocity and higher flow of water, and it's scouring and eroding away the natural channels at a rapid rate, and it's damaging the environment is what it's doing. So hydromodification controls in our current permit have a number of exemptions. There are certain reaches of waterways, and there are certain concrete line channels and storm drains and some other exemptions that we have in our current permit today that are not in this permit whatsoever. In fact, the only exemptions that we were able to get into this permit for hydromodification controls were existing storm drains and concrete line channels. However, again, if the municipality goes through the alternative area analysis and puts alternative compliance in place, they have the ability to look at the watershed and to determine where we can reintroduce some of the hydromodification controls. So again, this is probably a level of detail that landscapers may not deal with, but that engineers would definitely deal with. How we have to size the BMPs is based on pre-development. This was something that we argued about for about a year with the regional board. We didn't know what pre-development meant. We were fearful that it meant pre-Columbian times and that we were going to have to reintroduce a river on a project or something like that. But what they want us to do is to take a look at the project site, whether it's a raw project site or a redevelopment site, and use the underlying soils as what the calculation would be to size your best management practices. And we also have to avoid critical sediment yield areas, and that will be determined on a jurisdiction by jurisdiction basis. And again, a little bit more on the alternative compliance if developed in the WQIP or the Water Quality Improvement Plan. I can't stress enough that this is an optional watershed management area analysis. And why that's important is because each municipality may not do this optional analysis. It's a higher level of analysis that we have to do in our planning process. We have to look at mapping soils, all of the channels, whether they're natural, concrete line. We have to look at slopes. We have to take a much more detailed look at our watersheds and our existing infrastructure, where new development may go, our raw lands, and find out where we can introduce some of the hydromodification exemptions and where we might put off-site mitigation projects to mitigate some of the stormwater controls into receiving waters. So because it's an added burden and it's an optional approach, some of the jurisdictions may not take advantage of this. And where that's challenging for engineers and for landscape architects is if you go in to process a project, say, at the County of San Diego, and we've done this level of research and analysis in the watershed, you may be able to process a project and find some off-site mitigation or have some exemptions for hydromodification in that project. You may go, and I'll just pick on the city of San Diego because Joey's sitting over there. You may go to the city of San Diego and find that they didn't do the alternative analysis, and you would have to do retention on site. And so that's why it becomes problematic for these new alternative compliance programs. We're hoping that all of our municipalities will share in doing some of this, and in fact, we're taking a look at a regional scale, doing some cost sharing and some initial analysis throughout all of San Diego County to try to see if there's some level of initial or preliminary analysis that we can do that all the co-permittees can share, and then they can drill down into more detail on a watershed by watershed basis as we move forward in the water quality improvement planning process. The other issue with alternative compliance is that any alternative or off-site compliance project has to be done in the same watershed. It has to be done to a level that will result in a greater overall benefit to that watershed, and it has to be completed within 4 years of the primary project, the initial project, and the reason why you were doing alternative compliance being completed. So let's say you're doing a housing development of 10 units or more and you're a priority development project and you want to do some off-site mitigation because you can't retain everything on site because you're on D soils. You would go to your local municipality, find where you could do this off-site mitigation, and within 4 years of the development of the housing project, you would have to have fully implemented that off-site compliance mitigation project. I think that's all I have on that. So that really wraps up most of the technical aspects of this. Some of the other interesting things, as I mentioned before, there is a very heavily stakeholder-involved process that we're going to have to do as part of this new permit. It is required for developing our water quality improvement plans, and that means that we're going to be required, if you look at section F, and I didn't put, it's in E3C. One of the things also in Section F of the permit is the outline of what we need to take. We're going to be being asked not necessarily to take and implement data from other agencies or entities, but we're going to be asked to consider data, third-party data. So we're going to be developing a water quality improvement panel to help us with that process. And the water quality improvement panel has some criteria in this new permit, and the criteria is that one of the members has to be a regional board staff member, and those have actually already been assigned to us. So we know on a watershed by watershed basis who our regional board panel member will be. They have to be a member, there has to be a member from the environmental community, perhaps an NGO or somebody of that nature, and there has to be a member from the development community on this panel. So at a minimum, we have to have three bodies, 3 people on it: regional board staff, environmental community, and development community. Their sole purpose is to help provide recommendations to the plan, and in some cases to help us synthesize some of the comments and some of the analysis that we may receive and data we may receive from third parties. Now, there has been talk about how we're going to select those last 2 members, or if it's only going to be a 3-member panel, and none of the co-permittees have decided what they're going to do in their various watersheds yet. Everybody's considering, we may want more. We may want somebody from the business industry on there. In the North County communities where we have a lot of agriculture, we may want an agricultural professionals sitting up there to provide their input. So I don't know that this is how each and every panel will look in each and every watershed, but each watershed will have its own unique water quality improvement consultation panel to help in the development of that water quality improvement plan. So a little bit about our timeline, and I think that this is important to understand too. Our permit was adopted, as I said before, in May 8th of this year, and per permit language, it comes into effect 50 days after the permit was adopted, which was effective on June 27th of this year. Now, that doesn't mean that the regulations take effect June 27th at 8 a.m. What that means is the clock has started ticking for us municipalities to start developing all these work products and to ultimately update our codes and ordinances so that we can start implementing the new controls. There are 3 things that are going to be done simultaneously. One is the water quality improvement plan that I've been talking a great deal about today. That is due as a final product to the regional board on June 27th of 2015. So we have to have, as I showed you before, there's an iterative approach. We have to have our 5 minutes? I'll be done in 5 minutes. We have to have our water quality improvement plan, our goals, our strategies, programs, projects, all of that wrapped up in a neat bow and handed to the regional board by that date. We also have to update our what's called a jurisdictional runoff management program. It's kind of the backbone of our program. It basically talks about what the jurisdictions on an individual jurisdiction by jurisdiction basis are going to do to mitigate flows into other municipalities or into other areas. And it contains things like how frequently we're going to sweep streets, or what types of educational and outreach programs our jurisdiction is going to offer, those things that are offered at a higher level. But they also have to be engaged with and intertwined with the water quality improvement plans. So they have to kind of work together and be developed together as we move forward. That work product is also due that same time. And then finally, our BMP design manual. Now, I mentioned before we have a SUSUMP, or a Standard Urban Stormwater Mitigation Plan manual that talks about low impact development and hydromodification. We're now going to be calling it, it's going to be renamed to the BMP Design Manual, and it will also contain information on retention, hydromodification, low impact development, all of the things and new requirements that you saw, and alternative compliance that are in this new permit. So all of those things will be updated in our BMP Design Manual. Once that's done and completed and turned into the regional board, we then have 6 months, we as municipalities, to update our codes and our ordinances. So the watershed protection ordinance that you saw on the slide earlier will be updated by that time. That due date is December 24th of 2015. I don't know why we didn't get till the 27th, but we got cut off by 3 days. So we have to have all of those turned in and updated by that date. So really the clock starts ticking for new requirements to be in place, by or before the December 24th date. So that's when those things would come into effect. Some of you may ask about grandfathering. At this point, we don't know. The way the permit is written, it talks about lawful prior approval for projects, and that December 24th date is the other known that we have. We're looking for county and city councils to opine on what grandfathering will really look like when you bring a project forward. Now, I'm going to blow through the creative solutions because I think I have 1 minute. But today was all about creative solutions and what we can do. And one of the things I wanted to talk about was a fun little project that I'm involved in, along with several other partners, called the Sustainable Landscapes Program. It's a Prop 84 Integrated Regional Water Management, or IRWM, grant project. It's a partnership with 8 public and private partners, and I mentioned before we've got the County of San Diego, the City of San Diego, the County Water Authority is our lead agency on this particular project, Surfrider Foundation, the Association of Compost Producers, and the California Center for Sustainable Energy, all bringing forward a lot of good information and data, and some of our technical tools, like counties bringing forward the integrated pest management tip cards and the low impact development guidelines and fact sheets to the table. The city's bringing forward a lot of incentive programs. Our purpose is to develop a set of integrated guidelines, integrated curriculum, and integrated technical assistance, if you will, to create some of the best solutions for landscaping that will look at reducing potable water use, using rainwater as your first resource for water, mitigating pollutants, keeping things from flowing off-site, and creating healthy soils. So you create that sponge-like effect to hold that water on site so you don't have the runoff issues. So we're looking at those types of things. We got about a little over $1 million to develop this grant program, and that 1.05 million does not include the $350,000 that the partners had to bring in as match. And currently what we're doing is we're developing our integrated guidelines right now. We're in the process of doing that. So how would we use sustainable landscapes? Well, I mentioned before that we're on the hook for dealing with US EPA green streets. We may want to look at implementing rain gardens in parkways, and to do so we would probably use some of the guidelines and the guidance that we develop here through this program. We would use it to implement low impact development to meet our permit requirements. For landscape retrofits, of course, and that's the primary purpose of this project, is to retrofit, get rid of turf, and look at a more sustainable type of landscaping material. I'm sorry if there's any turf people out in the audience, but we're not going to use turf. To meet TMDL requirements, and of course, incentives with a $sign. And that was probably a lot more information than you expected to hear about MS4 permits, but I'm happy to entertain any questions if you have any at this time.
We just want to ask if you have questions or comments. There are 2 microphones. It's important to go to those if you can stomach it, because we're videotaping this. We're sending it all over the world, and we want everybody to hear your questions. So please go up to the microphones if you have questions.
Hi, Nick Martin, landscape architect. I just have a question. What is the current state of San Diego Bay and the San Diego coastline, the water quality in terms of bacterial contamination, which was so bad for so many years? Has it improved? Is it static? Is it getting worse? What's going on?
That's a great question. I would say the short answer is yes, it's improved. Our recent report cards have come out, and we've showed improvement. I could take your business card and give you more detailed information if you like, but we have had some improvements. A lot of it has to do with some of the programs and projects that we've implemented, but there's still progress to be made. Obviously, with the bacteria TMDL, the 20 beaches and creeks bacteria TMDL that was recently adopted at the regional board, and that we've already developed load reduction plans for, and we're going to start implementing as part of our water quality improvement process, we still have issues with bacteria. So we want to make sure that we get out and get ahead of that. And we have an 18-year time frame to reach certain goals and standards. Does that answer your question?
Almost. Is there a contingency plan to mitigate the contribution from our friends south of the border? Is that part of the program? You mentioned there's a pretty aggressive attempt to work things out, or?
There's actually the Tijuana River Valley and Tijuana Binational Program. Unfortunately, that's not my area of expertise, but I am familiar with the program. They are working on a binational committee, and that includes not just local planners and local agencies, but state and federal experts are also going down there, and they meet. I don't want to quote that. I think they meet monthly or bi-monthly on the issue, and some of the solutions are looking at new and improved infrastructure on south of the border. So, but we are getting a lot of cooperation, I do know, with that. Okay.
Hi, Sherry Monroe. I'm Riverside County area. We work primarily with Riverside County Flood Control. And we're having a real argument going on right now. Just want to know if this is addressed in the new permit. If we use some of the exempt materials, which we strongly recommend to all of our clients, and keep the amount of impervious area under the requirements for a project PD, do we still have to do a water quality management plan? Because it's a BMP, or if that's checked as no, we're not installing impervious because we're using an exempt product, do we then not have to do a WQMP, project specific?
I want to make sure, I'm going to repeat this to you and make sure I get your project. You're wondering if you keep your permeable surface calculations under that which meet the threshold in the new permit.
Right.
For like the 10,000 square feet or the 5,000 square feet. If you keep it under that, do you have to do a monitoring plan?
No, project-specific water quality management plan.
Oh, you would. There's minor swamps and there's major swamps. You would probably be, and I don't know the details of your project, but you would probably be subject to a minor swamp at that point. Actually, some of this is going to be fleshed out as we go through the water quality improvement planning process, and we update our codes and ordinances. And as we flesh that out, I would think at this time, if you're under the calculations in the new permit, you're going to have to implement the source control and the LID, because every project has to implement that at a minimum. But I think you would at least have to do a minor stormwater management plan.
Okay.
So, but you may check with Riverside Flood Control, Jason Yulee up there. He would be the best person to answer that question, or someone up there.
Thank you.
Sure.
I was just wondering if you could summarize what you think is currently the way small non-traditional permittees are going to be handled. You know, universities and the community college districts.
Phase twos.
Like that. You know, it seems to go back and forth kind of all the time. They're in, they're out, and it's kind of hard to keep track of. So I just wondering if you could summarize what you know of that, and if they're going to be in, who they're going to report to, and how that's going to be done, how that would be done. Like if they're in the city or if they're in the county, do they then report to the city or just report to the state directly? Is there going to be any sort of any sort of mechanism or trigger that forces a certain permit or a certain some approval?
And by small permittees, I think you're talking about the phase twos,
Yeah.
the smaller ones. My understanding is they report to the regional board, and the regional board issues them their permit. And as dischargers, they are required to meet the requirements of their phase two permit. Unfortunately, I'm not an expert in phase twos. I deal with this one, and that's enough. But if you give me your contact information, I can actually find out for you and give you more information on that.
Thank you.
Okay, sure.
Hi, I'm Jake Sibley with San Diego Canyon Lands. With regard to the 8 partners working on the Sustainable Landscape Program, could you talk a little bit more about what they hope to produce and the timeline? You mentioned guidelines and curriculum, but just more detail on that.
Okay. One of the things we were charged with when we put our project proposal together is 5 minutes. Okay. Is integrating the materials that we brought forward. And we had, when this project came forward, we had to apply for the grant funds, of course, and so we had to put a project proposal together. And part of that project proposal identified some of the guidelines that we would bring to the table for integration. So the County Water Authority has brought their Water Smart program and their Water Smart training curriculum. The City of San Diego brought, Public Utilities brought it was the incentives, right? All the incentive rebates, which is the rain barrel rebates and the turf replacement program. Thank you. Joey's my partner on that, so I'm looking at her. County of San Diego brought to the table some incentives, money, low-impact development handbook and guidelines and fact sheets, and the integrated pest management tip cards, which is the UCCAE extension integrated pest management for using more natural controls and minimizing the effects of, chemical herbicides, pesticides, fertilizers, those types of things. The Center for Sustainable Energy was supposed to be bringing forward some energy tree heat island index modeling, and I think they're still going to be bringing that forward. We haven't gotten to that part of the project yet. Surfrider Foundation brought forward the Ocean Friendly Gardens booklet and program, and their partners G3 have brought in some training components with that. And who am I? Oh, Association of Compost Producers. They're bringing in California. What is the name of that book? We call it the COOLIE, and I've forgotten what the acronyms stand for. Basically, it's a soils manual to talk about compost and healthy soils. So the idea is that we're going to take, and we've already developed a huge matrices of all of the key components of these documents, and looked at that and found out where we're pretty much the same and in agreement, and found out where we have some conflicts. And I'm kind of surprised we had very few conflicts. And those are things we can work through. But what our purpose is and what we're doing right now is we're integrating all of our guidelines, so we kind of have a best of practices that will come together and focus on those key things that we were trying to address with this integrated project, which is reduction of potable water, reduction of pollutants associated with stormwater and urban runoff, creating healthy soils, and then that heat island index component, planting more trees and reducing energy needs. Does that kind of answer your question? Yes, thank you. Yeah. And my contact information is on the slide there. If you need any more information, myself or probably Joey could tell you, because we're working on the integrated guidelines right now, and that's Joey and I's particular project on there. So, sure.
I have a question if nobody else does.
Okay.
Okay.
Are you allowed?
Sorry.
No critiquing my presentation.
Yeah. I'm verifying what I wrote down is correct. You said that, at least I wrote down, that using permeable pavement will reduce the number of BMP controls required. Did I write it down right?
You jumped way ahead, but kind of. Basically what it does is it reduces your impervious surface calculation. So you're at, just as in these example, you're at that 10,000 square feet if you implement a driveway, but if you implement a permeable pavement driveway, it reduces below that threshold. You wouldn't necessarily need to implement all 4 controls. You would have to implement the 2, the source control and the LID. So it would reduce you wouldn't have to do the treatment control and the hydromodification, I believe. So it's reducing the amount of controls that you have to implement. The regional board is really trying to get us to utilize more low-impact development type technologies and utilize those types of concepts. So
Okay.
more green infrastructure.
Okay.
Okay. Thank you very much.
Well, thank you, Stephanie. I do have one complaint. We need to add more acronyms into this whole thing. It just got a little boring after a while. I was waiting. I'd like to say that when we asked Stephanie to speak to us, or with us, she said, sure, I can speak for 20 minutes. And we thought, well, we're going to have a sophisticated audience. can you go into some more detail? So I believe this is the first time you've gone into this lengthy of a detail. If I'm wrong, just say yes anyway. So thank you very much. I have to figure out this. Oh, no, I got it. No, I didn't have it. Okay. When I get Belgard's up there.
Okay,
Right there.
this one, that's MS4. LID?
Yeah, go ahead. No, that's us.
So it's got to be the middle.
We practiced this about 20 times before.
That one?
Yeah. Okay, so the last presentation before our break will be by Belgard, who's helped put this on. I want to keep reminding you all of that. And of their presenters, we're going to have Seth Seaton, first to my left on the other side of Stephanie, and then Chuck Taylor, who often is thought of as the most interesting man in the world. And then John Scott. So thank you, Chuck.
You're most kind. Most people thought I worked for Converse. That was my first job, my first gig. Stephanie, I want you to know I have a couple confessions I need to make. I have never been, nor am I now, a backslider. And then as I talk, y'all realize I'm not from around here. And I do suffer from Midwest mentality, so I apologize. How do you make this thing move forward? This way? Okay. As design professionals, I'm assuming that y'all are familiar with segmental pavement construction or design or use. They could be concrete, it could be clay, it could be granite. They're typically, the way the Romans built their roads, there's nothing tough about it. They're designed to shed water. They're designed to last over 50 years. That would be ideal in a perfect world, but sometimes they don't get built as well as they should. And sometimes they get built over poor soils that weren't accounted for, and they don't always work. Now, with an effort to improve it, what we want to do is, oh my word, put water back in the ground, put water back in the pavement. That's a no-no. So I spent about 15 years learning about permeable pavement construction. And what I found is in the beginning I went to the internet and I Googled porous pavement. And I found that it was expensive to build, expensive to maintain. You couldn't drive heavy vehicles on it, and you couldn't use it in cold climates. Of course, in San Diego, that's not a problem for you. But where I come from, it gets pretty cold. Now, as I look at pervious pavement and porous pavement and permeable pavement, those are all terms that get thrown about. And what we want to talk about today is permeable pavement, because essentially all three products, or systems, if you will, are infiltration trench technology with some type of wearing course. And of course, we're in the business to make concrete pavers, so we want you to think about permeable pavement that are designed with a high PSI. They have long-term durability. They are able to be maintained. And one of the things Seth asked me to talk about for your group was water quality. And in the beginning, when I looked at doing permeable pavement design and how you create a system of moving water through pavement without damaging soils, it was, can the water really go through the pavement? And once you capture it, what do you do with it? And where does it go? How can I clean it? Because that always seems to be the big thing. So with porous materials, typically clogging will occur and you can't clean it. And with permeable pavement, we find that we can extract it, but in today's talk, we're not going to really cover about it. What I would like to talk about, we have high flow rates coming through the pavement surface in excess of 150 inches an hour. Even if it clogs 90%, you probably will still exceed your 100-year storm event in San Diego for sure. In the aggregates down below, we actually have large aggregates, you'll notice, that can store water. Typically, in a 12-inch cross-section, we can store about a year's worth of water for you San Diegans, how you pronounce that. So we're not really worried about the stormwater qualifications or the rate and flow. That train has left the station. One of the unique things about these products, if you look at the surface, typically you look at that surface as being a filter. And that's where the TSS, or your total suspended solids removal, occurs. And typically that's going to be in the neighborhood of between 70, 60, 70%, up to 90%. We'll look at some reasons why. Then the perception is all these particulates and fines, as they migrate through the openings in the pavers, all that dirt goes to the bottom and you lose the storage capacity. But what we're going to talk about is how these particulates and fines attach themselves to the aggregate in their vertical path travel, and they actually never make it below the first 1.5 to 2 inches of the aggregate joints. The only thing that's left is these molecular or microscopic pollutants, phosphorus, nitrates, hydrocarbons, heavy metals, particles, things that are below the 50 micron level. So what do we do with those? There's not a lot known. We've been studying permeable pavement or porous pavement or pervious pavement for quite some time, and we can sure tell you how fast the water goes through, but there's not very much knowledge about how good is the water coming out the back end, that effluent discharge point. And for me, the battle is there. The war is still getting rid of stormwater. What do you do with it? How do you treat it? How do you clean it? So we found some useful ways that we can actually capture and treat and provide detention storage and promote groundwater recharge where possible. We also do recommend using bioremediation as part of this process, and we'll take a look at how that works. Typically, there'd be 3 strategies. One would be full exfiltration. You have soils that are AB soils, sandy, gravelly soils are going to accept water infiltration rates greater than ½ inch an hour. So we really look at capturing all the water, putting it right back in the ground. But that's not a perfect world, because 80% of the projects I build end up being on clay soils. And I know we have all kinds of clay soils. We've got Georgia red clay, we've got Mississippi Yazoo, we've got California clays, expansive soils, Texas, yeah. But I got to tell you, this system will work. It's just that you have to use different approaches. So one of the approaches would be a partial exfiltration. As I listened to Stephanie earlier, capturing that 85th percentile in your market for, say, 1 inch of rain is like a no-brainer. We have a lot of studies we do in the Midwest, and Elmhurst College is one, where we captured water on a Elmhurst College site, and it took the first 3/4 of an inch of rain before there was any discharge from the site, which would be wonderful. It just coats the aggregates, it never comes out. But a partial exfiltration is designed on sea soils or soils that have less than ½ inch infiltration rates per hour. So you could have slower rates and still use this. But what we want to do is capture all the water, and then the water that's in excess of the first 85th percentile, it's allowed to discharge back into a daylight situation or a storm sewer or a river or stream. But the first flush pollutants have been captured and treated within this. Now, there are some thoughts about creating sumps and holding the water in this area longer. Normally, we want to look at 36 to 48 hour period of time, because they want denitrification to occur with time of concentration. That's a bad thing when you're building permeable pavements over clay soils. You don't want water to come in contact with the soils for a very long period of time. So the next process would be, I've got brown fields, I've got fatty clay soils, they're expansive. We don't want water back in the soil, so what do? So we use a no exfiltration system. So what now we're going to do is we're going to capture all the water, and we're going to discharge all the water and not allow any of the water to go back in the soils. And you have a choice at that point, is you can treat it totally to meet the water quality statements or requirements for the municipalities that you're in, or you can use it and recycle it. In some areas in Europe, they're actually using this water in the aggregates and putting it in closed-loop geothermal heating systems. They're heating and cooling their homes with this water, so it becomes an energy source rather than a nuisance. But once again, that's not about water quality. Now, what we did with Texas in Region 10, for TCEQ, because they have expansive clay soils, not unsimilar as you would find here in California, but what we're looking at, they gave us 89% TSS removal rate, and all we're looking at is the first 9 inches of system. So you have the paver, the setting bed, you have a layer of 57s, you put in a liner, and they use lime stabilization in their soils. So what we're doing is using conventional construction methodology in design applications to build roadways, but we're using the first 9 inches as a filter to capture and treat the stormwater. So that would be a good strategy for any pavement. Quite frankly, if I'd have done this 20 years ago, I wouldn't be here today, because this is such a simple thing to do. It's the right thing to do when you're doing pavement. So if you had the option to make it pervious or impervious, to me it's a very simple choice. Capture the water and do something with it. Now, typically, I've been coming to California for several years, and when I first came here, we talked to municipalities. I talked to them about LID, and they had that deer in the headlight look like, I got to give up my grass? No, I'm not going to do that. But in the Midwest or in the East, we use low-impact design or development, whichever you prefer to call it. But typically, I look at treatment train process, and so for me to use permeable pavement for capturing the first flush pollutants, using bioremediation for final treatment, it's like a slam dunk. It doesn't take a lot of thought process for that. Most regulatory agencies would certainly give you water quality credit for this process. Being landscape design professionals, you like to see the bioswales, I'm sure, but as a hardscape specialist, I must tell you, I don't need the bioswales to make this happen. But quite frankly, this is a standard operation, SOP, for us to build permeable pavement systems with bioremediation. Now, the irony is on this site, it's been in place for about 12 years now. It was designed by engineer, I call it, I forget where it doesn't stick to you. They don't want any responsibility. Teflon, I'm sorry, it's Teflon engineering. I apologize. I'm old guy. See, I get lost. I'm sorry. But they designed it to fail because they wasn't sure it would work. So they made it, if it failed, they would put asphalt over the surface. And you notice the cuts in the curb line. Then they would send the water to the bioswales where it would fund the growth of the vegetation in the bioswales. Well, after the first couple of years, it worked so well, they had to come back and had to irrigate the bioswales because none of the water made it to the bioswales. And of course, about the third year, the engineer's going, dang, oh, that's a good job I did. I sure like that. John, you want to talk now?
Talk about Encore?
Yeah.
Yeah, I guess, you guys hear me okay? So this project here that we looked at, we worked at with a developer in Florida, housing of urban development project for the city of Tampa. And essentially it was a 36-acre site that they were multi-use housing and things of that nature, mixed-use development project. And they wanted to retain and harvest their water. And so they called us and we talked to them over several months' time, and we talked about pre-treating the water in the system and retaining it, and also about sand filtration seemed to be the best way to go since it's a practical use. In this particular project, there's storm capture modules placed for detention. We pre-treated them with nutrient separating baffle boxes, capturing the first flush, sand filtration for water quality, and then up there at the top right, you'll see the overflow chamber with the pump well where it pumped the water back into the system. What it allowed the Encore to do was it actually saved them about 7 acres of their site. They're on a 36-acre site. And they were actually able to utilize that 7 acres for development rather than for water quality issues. So this particular site, they wanted to put a park in there, and with the park it had permeable pavers running through the pathways. It had green landscaped around the areas. The photovoltaic solar system was placed over the top of the sand filtration system, which provided power for the lighting in the park. And then the water irrigated was reused for irrigation on the site. So it was really a unique system. They were very happy with it. It took up about 3 acres of their site rather than the 7 that they were going to have to use, which opened it up for other uses for development.
Thank you. John Scott's with our precast division for Old Castle.
Right.
We have a link to the YouTube or video on this. It's a very exciting video for us to watch, a project that I've been involved with for a couple of 3 years, how this is going to be an integral part for downtown Tampa. Now, when I first came in a couple years ago to Old Castle, there was the old precast group that John's with, and they had storm capture, and we had the pavers. And I said, gee, it would be nice, because I can't use permeable pavers where I have high water tables. I can't use permeable pavers where I have a lack of aggregates, and maybe there's a more cost-efficient way of dealing with this. So we took a look at how the permeable pavers worked. Then we looked at storm capture, which was a concrete underground tank storage, and how it performs. And I said, well, why don't we look at maybe we can make a hybrid where we could have underground storage and we have pavement on top and we have a high TSS removal rate, maybe save some cost efficiencies. But once again, we're going to look at full exfiltration strategy where the water goes back in the soils. That's kind of a no-brainer. But what you end up is partial exfiltration, or if you have no exfiltration, the soils are so poorly absorbed you can't put water back in. So what we would need is the ability to take this water, store it, treat it, and recycle it for water harvesting. It may not be a strategy that's used in San Diego, but I know that Los Angeles is very intense right now about using water harvesting. So one of the things that we're looking at is some of the features of this system is that we can still give the client or the developer 50-year pavement design. We can be cost efficient going into the project, but more importantly, we can provide the municipalities the ability to inspect this, because typically the perception by municipalities, because they have this pipe or open ditch syndrome, is how do I inspect it, how do I clean it, and how do I maintain it? Well, with this system, we can certainly allow you to look down in a hole and stick a pump down there and clean it out if that's your choice. But more importantly for me, it was how do we look at capturing the first flush pollutants, how do we treat the water so that it can be sent back to the streams and the lakes in a clean manner, and make it so we can fish and swim in our rivers once again. So I think this system probably will answer that system process very, very well. So it becomes an underground system where it doesn't take up any land for the developer, and you don't have any surface retention requirements required. So you can utilize 100% of your land to build a larger footprint of the building, or increase your parking area, or improve your landscape process. Now, we also worked with Florida Gulf Coast University, the Flying Eagles, for those of you that are in the basketball arena. They were in the Sweet 16 this year. It just so happened we worked with Dr. Kim. Ooh. Was there any West Coast teams that showed up? Oh. Well, I'm in for it now. I'm going to start. Well, you guys can all get even with me tonight upstairs. There's not a problem. Throw me off the deck. Is it really? I've fallen farther.
About 50 floors.
Oh, that after the first floor. Doesn't really? It doesn't matter. Yeah. So we worked with the Dr. Kim at our Florida plant to look at what is the TSS removal rate. Does aggregates have an impact? The size of the aggregates? Does the sedimentation? What kind of sediments are we looking at for pollutants? How can we look at the removal rate? So what we're looking at are pavers set over setting bed over a concrete tank unit. We're looking at using some New Jersey CAT particles, and we're looking at using the aggregates between the pavers are either ASTM number 8s, number 89s, or number 9s, or number 10s. So what we find typically is the water does not go through the pavers. That would be the first perception. All the water moves through these joints, and these aggregates collect and attach the sediment to that. And I wanted to see what happens after a 20-year period of time, because typically I've been forecasting that the maintenance cycle would be about every 15 to 20 years. So some people have a perception that you have to extract the sediment every year. You have to sweep the surface to remove the dirt and debris with a mechanical sweeper, but you don't have to use a vacuum sweeper, and you don't have to put chips back in the joints. That's a very low maintenance item. So what we're looking at, these are some processes. We looked at the suspended solids concentration versus total suspended solids concentration, and they're close enough using New Jersey CAT particle mixes that they're considered to be the same. What we found through this testing process, that we also looked at winter sand using Ontario DOT criteria, that essentially, the larger the aggregates, meaning number 8s, which would be like a 3/8 top size, with the majority, no fines, it's all washed material, versus number 10s, which would be a 1/4 inch top size with a higher concentration of 1/8 inch aggregates, you have a higher percent of removal, let's see, when you have smaller chips. So what will happen is, if you want to have a higher sedimentation removal rate, you actually will clean it more frequently, because this number 10 clogged in about a 9-year period of time that was simulated rather than a 20-year period of time. The number 8s essentially allowed enough particulates and fines to pass through it. It never really clogged up in the 20-year period of time, which is pretty much true to what we're finding in the field of our installations. So we're talking about these total suspended solids. The manufacturers need to guide you as designers as to what products need to be used in their joints depending on your site or your requirements for that site or your municipality's requirements. So typically what we want to look at is, now that we know what the suspended solids is, what do we look at for the water quality process? And we looked at, like I said earlier, the New Jersey DOT and Ontario DOT, we looked at their 2 material gradations for TSS removal rate. We won't bog you down with these numbers because my eyes blur over. But essentially, we're looking at 60 to 75% TSS removal rate for either materials. And if we look at the particle diameters being less than 50 microns in terms of stopping those larger particles, we find that both materials are about the same. So essentially what we end up saying is that we get a 70% removal efficiency for New Jersey material or 100% removal efficiency for Ontario material. And then if we look at, typically we have a statement that might be 70% that we will be at a minimum to achieve 80% TSS removal rate. So it's kind of a trade-off. Whatever sediment loading you use as municipalities, you're going to have about the same performance requirements. So here, I think the question came up is, we have beach sand, how is that going to be impacted? Well, I have to tell you that based on the workshop study that we did at Lyle Arboretum, for Morton Arboretum in Chicago, after about a 9-year period of time, we actually did a workshop that looked at what happens to the particulates and fines as it migrates down through these joints. Where is it going? Because the DuPage County officials said, well, we think that all those particulates go to the bottom of the aggregates and you lose your void storage, so you can't store as much water, much like sedimentation in wet detention ponds or retention ponds. You lose your volume storage over time, and then you have to dredge it back out because it no longer meets the capacity requirements with time. So what we would suggest to you, that your concerns over the percent of TSS removal rate is not as critical, because the aggregates actually travel about the sediment travels about 1.5 inches to 2 inches as shown here in this removal of the pavers, so that in the area below here, there aren't any more sediment particles traveling. We have another, when Seth would come to your office, he would talk more in depth about this process. But what we're finding is, you see the white aggregates in the first picture on the left, that actually is your setting bed material, and we looked at the particulates and fines. They never moved into that area. So what's really moving into this area below that pavement is the microscopic pollutants, the phosphorus, the nitrates, and things, and hydrocarbons. Now, there are naturally occurring enzymes on the aggregates that establish a bacteria colony that break down these pollutants over time. But the problem with doing flexible pavement construction is you don't really want time of concentration to exceed this 24 to 48 hour period of time. So what we're thinking is possible is that we would look at underground tank construction, and then we would capture the water 100%, because the C value for this system is 0 till you exceed the capacity to store the water. Then the water would be stored and then treated on demand as it's discharged either to a daylight or a storm sewer. And you could mitigate the peak flows by having a control mechanism so your discharge flow rate doesn't exceed your hydromodification requirements, as you use the term out here. We don't have that in the Midwest. We just call it, don't let her go too fast. or you can actually capture this water and use it for water harvesting. Now, we're currently doing some additional research where we're actually going to take particles of glass, if you will, but we actually will put these in the joint materials to help improve the water, because all we need is water contact flow through, and it removes all your nutrients, your pesticides, your chlorinated solvents, and it's been approved by the EPA in Ohio, Kentucky, Indiana, which I really know that sets you guys in California off. I mean, you guys got what is it, CBR value, and you don't even like it, you don't use it for the California bearing ratio? Come on. But nonetheless, we're going to have to come out here to California. We're going to have to show you that this stuff works, because I know you're all from Missouri. Well, that's how it works wherever I go. But anyway, what we're looking at here is the runoff running through a bioswale with a soil mix containing these powders, and we're actually working now to incorporate those into the joint aggregates. And the other process would be is we're going to take concrete tanks, capture the water, possibly because you have a lot of sites here with expansive clay soils, so it'd be a linear system. So you'd run them into a discharge point, you'd build an outlet structure, then we'd have bags of material that would go into this tank, and you have a weir built so the water would pass through it, and you could immediately discharge it back into your streams. So, with that being said, what we'd like to have you consider is that when you have rainfall, we wanted to improve water quality. One of the things that we'd like to do is look at mitigating peak flows so that we reduce the scouring to downstream rivers and streams, promote the ability to recharge groundwater where possible. We actually have a cooling. We can reduce thermal pollution by evapotranspiration of the water on the aggregates. We actually can use photocatalytic cement with nanotechnology. We can make the pavers with a cement that is activated with sunlight, and it improves air quality by 50%. We can use light-colored pavers that impact LEED projects, and as part of a 26-point credit that pavers will bring to LEED projects for USGBC. But anyway, we have the ability to use light-colored pavers that meet the SRI value. We also have the ability to harvest and capture this water. So, I think somebody said something about being a decider. We had a president. You're the deciders. You decide whether you want to use this. You have the ability to make the difference. My job is done. So are there any questions we can answer? Thank you.